All right, so what we have going on, we're going to start new unit, lines, angles, activity. Basically, the lines are going to be mainly parallel. So I forgot to write that part. Parallel lines and angles activity. You will have a short homework assignment. It's not going to be due until, not next class, but the following class. So basically, it's just going to be about, and it's not going to be a whole lot. All you're doing is just matching angle types. So really, you're not going to have to do much math, but I still want you to understand the angle types because the following homework, you're going to need to know the angle types, which we'll go over in a little bit. You're going to need to know their relationships. That's going to be the key. You don't know, you have to understand the relationships, which we'll talk about together as well. And that's a lot of what's going on, similar to your last quiz and your last test. If you understood the relationships with your angles, what type of angles you have, what the relationship is, then you're going to figure out, do I add them together to get to a number, or do I set them equal to each other? That's what we have going on here. Because, and it's going to be similar, like what we're going to do next is similar to what we did before. Rather than just an angle with another angle, or, okay, the two angles together, they're either 90 or 180. We're going to have to figure out, are they equal to each other, or do they add up to 180? That's what we have going on here. That's going to be our goal. So, in fact, I'm going to put the word parallel in parentheses because I think most of these activities are going to be parallel lines. And again, your homework, it's going to be a quick assignment. It should not even take you that long to do. It's just more of the identifying. So basically, you're identifying what type of angles you have. And then basically, on the other side, you're just saying whether or not if the angles equal to each other or the two angles have to add up to 180. And there's a little trick to that. Okay. There is a chance we may not get through this whole packet today. So you may have to bring it back next time if we don't get through it today, okay? Because definitely keep it, because the stuff that we do today, depending on how far we get, will be good for your next homework activity. So don't lose this. Also, I'm around after school today. I'll be next door, 8224. Progress reports, they're given to you. Check to see what you need to do. And your test grade is also part of that progress report. If you need to make up the test, we need to get that done ASAP. All right, so here we go. On the first page, let's see if I can show them. The only ones I kind of want you to worry about, well, the parallel lines, that's the number one. This is the one, think about like railroad tracks. If you know, when you see railroad tracks, do the two rails cross each other for the most part? No. So parallel lines, think about railroad tracks. They will never intersect. And if there's time, we'll talk about same slope too. Parallel lines, same slope, they will never cross. They will never touch each other. Now, don't worry as much about a skew line, but the best way to think about it, pretend here's like this is a bridge, right? You're walking on a bridge. What's usually under a bridge? Water. Now, are you ever going to touch the water if you're walking over the bridge? No. That's an idea of a skew line. You're on one plane, pretend you're walking on a bridge, the water's underneath you, but you're not going to touch each other. That's all that really means. I'm not going to think too much about, but skew lines, that's the best way to think about it. You're walking on a bridge with water below you.
Please pardon the interruption. The protest has now ended. Please allow students 3 to 4 minutes to get to class.
Okay. All right. So that's the idea of skew lines. Saying you're walking, river's underneath you, or you're on a bridge crossing a highway, like the cars are underneath, but you're above. Now, parallel planes. Think of a room. Think of the ceiling and the floor. Do the ceiling and the floor ever touch each other? No. So that's an example of parallel planes. Think of a room, ceiling, floor. So if you want to add that, you can. So that, and then this one, perpendicular lines, they cross. Now, right angle. How many degrees was a right angle? 90. So 4 right angles. Those are 90-degree angles. Remember, we're going to be dealing with that. It's going to be something you're going to need to know in and out all year. Right angle, 90 degrees. It's a right angle. So all 4 of those guys down here, 1, 2, 3, 4, they're all going to be 90 degrees. So you might as well, if you want to, you could write 90, 90, 90, 90. So that would be for all 4 cases. You don't need to, but you can if you want. Questions up to this point? Those are the only things I really want to talk about this page. And the one that we're going to talk about the most is this guy today. This is going to be the star for today. Questions? Oh, my stars are not too well today. All right. All right, here we go. But this is the big one. Because we're going to talk about this when we do our activity for today. All right. Next page. Put a big fat X. We're not even going to talk about this. Put a big old X. The whole page. I'm not going to deal with that page at all. It's not going to be. So don't even bother with that. Because I think on the Unit 2 test and your homework, or the Unit 3 test and a homework, we're not even going to deal with this. Let's just save time. The reason why I'm going to say that is, yeah, again, you're not going to see it on the. Now, here we go. This is where I want us to be. All right, good afternoon. Take one and a calculator. And we're on the third page already. You didn't miss a whole lot at all. You need a pencil. Okay. So this is where I want us to be. Okay, so gotta get rid of it. No phone. All right. Transversal. I'm gonna highlight what the transversal is. The transversal is that line that's going across. So it's this line right here. I'll show you. This line right here, that's your transversal. It's intersecting two or more lines. So your transversal is going to cross, we'll say the railroad tracks. You may cross another line, that's fine. But think about that line cross, so think about the road that crosses the train tracks. No, get it from there. All right. So the transversal, it's that line. Think about the road that crosses the train tracks. Now, here's what's going to happen. Here's where I really want us to focus. The relationships. I want us to focus on the relationships. So I'm going to zoom in a little bit. The first thing I want to talk about, corresponding angles. Corresponding angles. Think of it as the same spot at the intersection. So I want us to focus on the diagram. So for instance, I pick angle 5. Look at your other intersection. Which angle is at the same spot as angle 5? So look at 5, it's in the upper left. So if you look at this other intersection, upper left, look at the bottom. So it's 5 and 4, they're corresponding. And then let's say if I had 8, which one corresponds to 8? 3. That's what we mean by corresponding. Now, there's going to be a special case with the corresponding. So if the lines are parallel, we're going to talk about relationships. And for most of the problems that we're going to do, we're going to talk about the relationship. So if they're corresponding, they have a relationship. Now, alternate exteriors. Exterior. When we think of exterior, outer, like exterior of the house, outside, very good. So it's going to be outside the parallel lines. So another way to think about it like this. Outside parallel lines. So they're going to be, so these angles are always going to be outside the parallel lines. Or outside, I'll put parallel in parentheses. I'm going to put parallel in parentheses because for the most part, these lines are going to be parallel. They might not be all the time. But usually for the homeworks, in the tests, quizzes, think about it like choo-choo train tracks. They're going to be parallel. They're never going to touch. So outside parallel lines. And then So we listed the examples. So for instance, angle 5, angle 8. They're outside, but they're going to be opposite. Notice how 5 is on the left side, 8 is on the right. Do we see that in the diagram? Similarly, 7, 6. Notice how 6 and 7, they're outside, but they're opposite of the transversal.
So I have a question. When we talked about alternate scenarios, will it always be like the ones at like the very top and the very bottom, or will it also be like the one in the middle?
If it's exterior, it's either going to be the top or the bottom, or I'm going to show you another diagram. You brought up a good point, Amy. You could have something like this, too. You could have somewhere, but they're going to always be outside. So good question. Because the diagram, we just inverted it a bit, like we turned it sideways. But yeah, it's the same. Exterior, they're going to be outside the two parallel lines. So they're going to be not between the tracks, but outside the tracks. Whereas the alternate interior, they're going to be inside. And I'll put parallel. Because usually they're going to be parallel lines. So alternate interior angles, they're going to be opposite, but inside. So for instance, inside, opposite. So for instance, number 4, number 3. Notice how 4 and 3 are inside, but they're opposite. They're opposite that middle line. 1 and 2 are the same thing. You have angle 1, angle 2. Questions? So give you all a moment, because we're going to have to study these trends, study these diagrams. In a minute, you're going to do a practice activity. Again, know whether you're outside or inside. And again, think about exterior of the house, interior of the house. That's where we're going with this. Questions, anybody? Again, if you need highlighters, highlighters are over there. Then the last one I want to talk about, this one's going to be huge. Now the consecutive interiors, unlike the alternate interiors, consecutive interiors, they're going to be same side. They're also going to be inside the parallel lines. So I'm going to highlight these examples. So 3 and 2 are inside the parallel lines. And 1 and 4. But notice, unlike alternates, you had a crisscross, consecutives are the same. So notice the big difference between these two guys. You have to understand that big difference. So give me a moment to look at it. Consecutive interior angles. Interior angles, same side. So that's why 1 and 4, 2 and 3. So now what we're going to do, we're going to take a couple minutes. We're going to look at a diagram. And we're going to figure out which one of these 4 scenarios, or it might be others too, which one of the scenarios do we have? Now, I think there might be a couple where it might be totally different too. Might not be strictly these 4. Because I know I want to talk about some other things as well that were from before today. So let's talk about.
Can you go back to your corresponding one?
Yeah, corresponding. Same spot, so I'll go back to that, Brooklyn, no problem. There we go. Is that good? All right. Let me zoom that out a little. All right. You got it. So I'll actually put it right here. Because now we're going to talk about this next activity. For the next 4 problems, we're going to pick 2 pairs that satisfy each of these 4 relationships. Pick at least 2 pairs. So let's talk about the corresponding first. Corresponding, again, what are we looking for? Same spot, so that's a hint. You want to write same spot as your hint, do it. So yeah, corresponding, same spot at the intersection. So that's your idea for corresponding. You can write it above, you can write it below, don't matter. So, all right, I got an idea. Somebody pick any angle for number 1. Pick any angle that comes to your mind. Raise your hand. Nelson. Okay, angle 1 and angle 5. Angle 1 and angle 5 are perfect examples. Because do we agree angle 1 and angle 5 are in the same spot at both intersections? Exactly. Somebody pick another pair.
2 and 6.
Okay, 2 and 6, do we agree? Angle 2 and 6 work. All right, I agree as well. Angle 2, angle 6. Again, same spot. Good. Questions on the first one? Now again, you don't have to write it out. If you wrote it as that symbol, that's fine. Like, see that little, it looks like a lowercase L or a slanted L. If you did that, that's okay. All right. What about consecutive interior angles? So the consecutive interior, first off, is it inside or outside?
Inside.
Okay, so you're going to be looking inside. Now, are the consecutives opposite or same? Inside, same side. Yeah. All right, so here's how we're going to solve that one. Somebody pick one angle that's within the parallel lines. All right, so we said angles 3 and 5. Are 3 and 5 on the same side? Are they in? Angle 4 and 6 also works. Very good. Angles 4 and 6. That also works for a consecutive interior. Any others, or is that it? That's it. You don't go anywhere else. Inside parallel lines, same side. Good. Now what about alternate interior ring?
angles that lie on opposite sides. So it's inside the opposite sides.
Inside opposite side. Very good. Inside opposite sides. Well done. Good answer. So therefore, all right, somebody pick an inside angle. Angle 4. All right. Angle 4 and, well, be careful.
4.
Inside, but they're opposite.
Oh, so it's 4 and 6.
4 and 6 are on the same side.
3 and 6. Oh.
You can go 3 and 6. That's one option. Because they're inside it, but they're opposite. So,
Shouldn't it be 3 and 4 too?
not exactly because
Oh, 4 and 5.
4 and 5 are going to work. Yeah. Yeah, because, all right, now we should be careful. And it should be inside, but they're also going to be, besides opposite there, because 3 and 4 look like they're on the opposite. We should say inside, but diagonal. Inside, but then crisscross, like opposite side. So it should be like a diagonal. So we better be careful with inside opposite. So diagonal opposite. That's it. Diagonal opposite. So if you want
Alternate, it's outside opposite side.
outside opposite. Now, are we talking, is it going to be outside but the same side, like 1 and 2?
Opposite sides. So it's gonna be 1 and 2. Angles 1 and 2.
Well, be careful. Are we going straight across, or are we going diagonal?
2 and 7.
2 and 7 are going to work. So it's outside, and I'll write the word diagonal. That might even be better for
And then
us.
angles 1 and 8.
So yeah, in fact, if you want to add the word diagonal, we'll go back to the notes in a second.
Angles 1 and 2.
1 and 8, and what other one, Brooklyn? You said it.
2 and 7.
2 and 7. Angles 1 and 8. Very good. That's what we need. That's exactly how we do it. Very good. Yeah, so really, if you want to get real correct, outside, but we should say diagonal opposite. Not just straight across opposite, diagonal opposite. So you want to add that word diagonal in your original notes. So sort of like what we have down here. You want to add diagonal. Notice how they crisscross. They're not same up and down. They're not same right to left. It's a crisscross, sort of like a zigzag. And I'll give you an idea in a moment. So, anybody have any questions on 1, 2, 3, or 4? All right, now, for the bottom part, we're going to use one of these, but I'm going to add, there's going to be a couple others I'm going to add to it. You're going to see why in a second, because it's going to be sort of like what we did towards the end of the last unit. So we're going to look at this, we're going to keep with the diagram. We'll keep with the diagram for the moment. And then we'll go from there. All right, so let's keep with this diagram. But now we're going to start looking at, given what we see here, you're going to fill in most of these blanks down here, but be careful. All right, let's look at. We're gonna first look at angles 3 and 7. So here's 3. Here's 7. What type of relationship do angles 3 and 7 have?
Corresponding
That's what I thought.
Why?
because
It's the same thing, but just opposite. It's just split.
All right, they're going to be corresponding angles because 3 and 7 are located in the
same spot.
same spot. Yeah, 3, 7. See, same spot at the intersection, bottom left. So yeah, that's the same spot.
And then 6 and 3 is going to be alternate interior.
6 and 3 are going to be alternate interiors. Very good, Brooklyn. No, you're right. Here's 6. 3's right here. So that's going to be alternate interior. Excellent. Yep. They're alternate interior because it's inside, but they're diagonal opposites.
And then 9 is alternate exterior.
All right. So 9, 2, 7. Alternate exterior. Exactly. And
And then 6 is consecutive interior.
why is it consecutive interior angles?
Because they're on the same side. They're both inside.
Consecutive interior angles. So it's going to be same side, inside.
And then 8 is corresponding.
Oh, all right, here's where this
Oh,
is.
never mind. I was looking at the wrong colors. My bad.
No, that's all right. But look, I'm glad you said what you said, though. But they're going to be similar to corresponding in the fact that,
Oh, yeah. 'Cause it-
but are they? But there's another name. It goes back to Unit 1. This is some older stuff.
vertical?
Why vertical?
I don't know. I just said vertical.
Because they're in the same spot.
No, they're on different sides.
Okay,
Different sides, but in the same spot.
okay, so, all right, I know where we're going. Okay, here's what's going to happen. You both are kind of right. Vertical, now I know why you want to say the same. They have the same measurement.
Oh yeah, they actually do look like they're the same.
So 1 and 4 are actually, and the reason why I wanted to bring this up, because sometimes we're going to still see the vertical angles.
So what would 8 be?
Vertical angles. So when you said vertical angles, that was actually correct. This is Unit 1 stuff, but this is correct.
Wouldn't 5 and 7 be vertical angles? Oh, never mind.
Yeah, no, yeah, because with 7, 6 is,
It makes it more, the 5 is much longer than 7 is much shorter.
well, and not only that, but yeah, with 5, 3 and 7, they're not directly,
Wouldn't 5 and 7 be corresponding?
not totally, be careful with that. But but there's something else. That's from Unit 1. If you look at 5 and 7, what do they form? Let's say if this arrow did not exist between 5 and 7.
Triangle.
Not right angle.
Straight angle.
It's a straight line angle, but there was another word they add up to 180.
Commentary. No, something.
They're going to be supplementary. All right, I'm not going to disagree. They will be supplementary. But does anybody remember why they might be supplementary? It's two words. First word begins with an L. The second word begins with a P. 2 words. And line is part of one of those words. So they're supplementary, I'll give you that. Not so much. Well, they're supplementary angles. Okay, I'm not going to disagree with that. But they're called linear.
Linear pairs.
That's a linear pair. Because it's a linear pair. They're supplementary angles because they form the linear pair. So the linear pair is what we really wanted. But they're yeah, it's a linear pair. They're supplementary because they're a linear pair. That's where I wanted to go with this one. And some of us on the test, when it came to that very last problem, some of us on the test struggled by adding them up to 180. So supplementary angles, linear pair, add up to 180. That's something we will be dealing with in and out all year. We're going to be dealing with that in and out for the rest of today.
What is in 90 as well? Like, since it's supplementary angles for us to see degree angles, we have to.
You might. I'm not going to throw that one out. Like for now, probably not. But don't totally throw that. We'll never see away. You'll see it again. Not so much right now. But this is going to be more important because when we do some of these problems, you're going to still have to understand the linear pair, like the angle when the 2 angles are next to each other. Okay, does anybody have any questions?
It's gotta be on school review for the pages.
Yeah, and you really didn't miss a whole lot, but yeah, because the second page, the one if you see like the 2 cubes, the 2 squares, we're not even touching that one.
So we just did the first page?
Yeah, you only missed really the first page, and really you didn't really miss a whole lot. But I will post on Schoology regardless. So, all right. Now here's what we're gonna do. On the next page, I realized this part right here. The only ones, and I will show you. 1 and 5. Well, 1 and 5. What if we had 1 and 5? What would these guys be? There's a couple options. No, somebody said it. 1 and 5. What would be the relationship with 1 and 5? That's going to be a linear pair. Now, yeah, we'll just go through this real quick because I don't think you're going to see something like this on your test. Now, 2 and 8 don't even bother. That's a cross out. I don't think I was even going to do all these. Yeah, 2 and 8 was a cross out. 3 and 11 you can do because similar to before, 3 and 11 are in the same, what? Spot, so they are corresponding. Good. Yeah, you can cross out number 4. Yeah, 4 is a cross out. Don't even bother with 4. And going forward, there's going to be times where I might just say, here's the note, show me what you've done. If you've crossed out the correct spots, that tells me you were paying attention. Does that make sense what I'm saying? Cindy, did you cross out problems 2 and 4? All right. You cross out number 5. Now you could get this last one, even though it's slightly different. Does anybody want to take a guess?
Alternate exterior angle?
Close. Right?
Interior.
They're going to be interior because even though this guy looks like it's outside, it's within this other pair. Whereas 11 was definitely inside.
It's going to be alternate interior?
It's going to be an alternate interior. Now, I don't think on a test or quiz, you're not going to see anything of this type. It's going to mostly be like half, like either top half, right half, left half, bottom half. You're not going to have something this big. I just want everybody to see, though. This was just a quick. Yeah, I didn't. But you could, rare. I don't think I did this on a quiz or a test, but there might be times when you could see a diagram with 2 sets of parallel lines. I don't really want to spend much time on this. Not at all. All right, questions on this? So similar to what we did before. Yeah, but these 2, 4, 6, 5, yeah, we're not going to deal with those. Now, what we're going to do next is going to be really important. So you see on the bottom part, you have 5 scenarios when we're dealing with angles. Now, this only works if the lines are parallel. These rules about supplementary or congruent are only going to work if this line crosses 2 parallel lines. So I want you all to highlight this part right here. This has to happen. The 2 parallel lines, you must have that. Two parallel lines, you must have with that transversal. If the lines are not parallel. Now, I think on the quiz and the test, more than likely, this is going to be the case. So if I give you a problem, like what we're going to do some today. I give you the problem. You can assume that line is crossing 2 parallel lines. Now, the first thing we're going to talk about, and we're going to do the act. You might want to do this. Don't break it, but like do like an eagle, like spread the wings out. You might want to hold it like, set up your notes like this. So, yep, there you go, perfect. All right. So what's going to happen? And I think the first activity is just going to identify one more time about just identifying. So let's see. Corresponding, they're going to be congruent. So I want you to either highlight, do something. So if it's corresponding, congruent. It means you set them equal to each other. So corresponding, set your angles equal to each other. Because that's where we need to see. So I tell you, okay, this angle, this angle. If I give you an expression for each angle, you see, oh, they correspond, set them equal. I think that's what the problem was on the test for some of us. We didn't know if we had to set stuff equal or we had to add the two angles up to a certain number or add the two segments up to a certain number. That was a problem. So corresponding, if you see they're in the same spot, set them equal, solve. Alternate interior angles. Same thing. Set angles equal to each other. Again, same thing. Set angles equal to each other. So you see, if you have alternate interior angles, sorry, I'm sounding like a broken record. Set equal to each other. All right. Consecutive interior angles. Oops. Unlike the previous two, add the two angles, set them equal to 180. Sum of the two angles equals 180. So supplementary means sum of the two angles.
You're basically doing what you did in the last one.
Right. Now the only difference is in the positioning of the angles. Because on the first test, they were just straight across. Like in the past, we had, let's say this was angle 5, this was angle 6. They were on the same line. But they had the same side, whereas here they have they're on the same side of the parallel, but they're different. Like they don't totally share the same side. It probably doesn't make sense. But it's positioning. So it is very similar to what we did before. The only difference is the positioning. And the alternate exteriors. They're congruent. So you need to set those angles equal to each other. Now these are the main four we're going to deal with. So 3 out of 4 times they're going to equal each other. And maybe that one time they're going to add up to 180. Now, I don't think this one is also, we're going to rarely deal with this one. We're rarely going to deal with this, the same side exterior. Really what's going to happen is I'm going to more than likely give you a corresponding and then just take away from 180. That's how you're going to get the other one. This one more than likely we're not going to talk about. It's very rare. They're just saying in case you get stuck. They gave you this angle, they gave you that angle. These lines are parallel, then the sum of the two angles are 180. But you're rarely, I don't think we're really going to cover this one on a test that much, but it might be something good to know. But out of those 5 cases, I would stress the least amount on the bottom one. And it's more for, okay, we talk about it, but you're going to be more responsible for the top 4. Now, you're going to want to keep the pages like a spread eagle when we start talking about the next set of problems. So keep them out. All right, so let's talk. So that's why you're going to need it, because then you can look right away on the other side. Okay, this is my relationship. What do we have?
Isn't the first one postulate?
Postulate, yeah, the postulate or theorem. So basically, which one of these guys, corresponding, alternate interior, consecutive, interior, alternate exterior? That's all we're going to answer for these first 1, 2, 3, 4. Now, number 5 is going to be a little different because it's not going to be one of them. But you'll know right away once I highlight what type of angles you have. So if you look at the first one, 1 and 5. Okay, don't worry about the words up here. I have 1. You're going to answer by using one of...
Is it corresponding angle postulate?
Yup, or just corresponding angles. That's all you need to write. But that's how you're going to answer. It's going to be one of these 4 guys right here. So number 1, corresponding angles. Just write corresponding angles. And that's it. You move on. Okay, what about number 2?
Alternate interior and rear.
Yep, they're going to be alternate interior. Alternate interior angles. So that's number 2. And then don't worry, I'll separate.
And then 3 is going to be alternate exterior.
All right, so number 2, I just want to get this. And then Brooklyn said 1, 8. We agree, alternate exterior? You agree, Richard? Why? Well, can you tell? Why was this correct? Why are they alternate exterior? Where are the angles located? Inside or outside the parallel lines? Outside parallel lines. And are they on the same side? Or are they on different sides of the line? They're on the, okay, that's exactly what I wanted to hear. Now, look at where number 4, angles 4 and 6 are located.
Consecutive interior.
Why consecutive interior?
You guys all the same side.
All right, so there's number 4. Number 6. Consecutive interior, very good. Oops, consecutive. Consecutive interior angles. Yep, good. Now, 7 and 6 are a little different. It's not what we've seen before. Well, we've seen it before, but not earlier today.
Isn't it the near here? Okay.
Close. So here's 7. Look where 6 is compared to 7. So here's 7. They're going to be verticals. All right? They're going to be verticals. Vertical angles, that's right. Good job. These guys are going to be vertical angles. Oops. All right, questions? Anybody have any questions on?
Are we getting more?
You will. But it's not going to be a whole lot, because basically your homework is going to probably be, if you understand this part right here, that's really going to be the only thing you have to worry about for your homework. It's a very short, quick homework assignment. So if you understand what you see here, that's half your homework, and your other half is going to be what we're doing here. You understand all this? That it's going to be a very quick, easy homework assignment. You can probably have it done by next class. It should only take you maybe about 15 minutes max. So yeah, very short. All right. So let's talk about okay, so let's talk about this part down here. So look, oops.
It says measure angle 1 equals 125. So if 1 equals 125, 2 equals 125.
Oh, be careful. We need to talk. Let me zoom out a little. Yeah, might be a little too far out. Okay, maybe that might be good enough. Okay, let's talk about that. So angle 1 we said was 125.
So if 1 is 125, it probably means that like 5 is 125 as well.
Okay, why do you want to say 5 is 125 as well?
Because there are like some
All right, 125 will also be for angle 5. Good. So right away, corresponds with angle 1. So that might be a way because they correspond. Good. So angles 1 and 5 correspond. Corresponding angles. Good. That's exactly. Okay, so 1 and 5, they correspond. That's why they're going to both be 125. Now, let's look at number 2 in relationship to number 1. What does angles 1 and 2, what do they form? Their total is 180. So
You have to see what number adds up to 125.
So
I think it's like 60.
angle 1 plus angle 2 equals 180. So the goal is you need to subtract.
It's 55.
Angle 2 is going to be 180 minus 125, which is 55 degrees. Yes.
So if number 2 is 55, number 6 is 55.
Number 2 is 55. That's right. Number 6 is going to be 55. 55.
Aren't they also corresponding?
2 and 6, yes, they correspond to each other. So yeah, they have the same. Yep, so basically angles 2 and 6 are just like angles 1 and 5.
So what angle would they for doing the
So say again?
what angle would they be then?
What? Which ones, Amy?
2
The corresponding angles. So it's similar to 1 and 5. 2 and 6 correspond.
Can we see that thing?
Now we need to talk about the other ones. 3, 4, 7, and 8. And I'm going to give you a hint. Once you know these guys, you'll get the others. Because we have to use corresponding or consecutive interior. Well, we might have consecutive interior. But there's now multiple ways you can get 3, 4, 7, and 8 as well. So let's look at angle 3. What could we use from items 1 or 2 to determine the angle measure for angle 3?
125
Mine is
Oh,
not divide. For angles, so let's look at angle 3. I'm going to zoom in on angle 3 a little.
they're congruent.
Who's congruent?
3 and
Okay, 3 and 6 can work. 3 and 6 are going to be congruent. I'll give you that one. It's going to be 50.
I thought we were alternate interior angles, right?
That's right. Angles 3 and 6 are alternate interiors. Very good. Angles 3 and 6. And I'm just going to abbreviate. Alternate interior angles. Yeah, 3 and 6 are alternate interior angles. Very good. This is 55. Can we get any other angles? So 55, 55, 55. Which other angle might be 55?
Wait, you didn't do anything to the 3, right?
What do you mean?
You didn't like subtract or divide.
Not necessarily. I mean, you could subtract, but it's 180 minus 125 is 55. But, Cindy, we also know that angle 3 and angle 6, since they're alternate interior angles by parallel lines, they're automatically going to have the same measurement. That's a rule. And again, you don't have to solve all these in order. Notice how we jump from 2 to 5 to 6, back up to 3.
Question.
Yeah.
Would 8 and 4 be consecutive material?
Not 8 and 4. They have another relationship, 8 and 4. But 4 now you could have consecutive interior angles. with 4 and what's on the same side as 4? 4 and 6 are going to give you the consecutive interiors.
Oh, 4 and 8 would be alternate exterior. Right?
Not
No,
4
that
and
would
8.
be 3 and 8.
No, not 3 and 8. Remember, 3 is inside, 8's outside. So, but I like where you're going. I like your thinking, though.
Okay.
Your thinking's pretty good. But 4 and 8 have another relationship.
Oh,
However, let's make it even more simple. Angle 4. We just look right here. Don't even have to look beyond here. What would be that measure? What would be angle 4's measurement?
55.
Not 55. All right, I have another idea. Just let's zero in right here. 1, 2, 3, 4. Notice how 2 and 3 have the same measurement, right?
Would be 125 though?
Angle 4 would be 125 because angle 4 and angle 1 are begins with a V.
Vertical.
Vertical. So you can use that too. Angle 1 and angle 4, vertical angles. Now we have 7 and 8. Those are the last two angles. We're going to use angle 7. Who wants to take a guess as to what angle 7's measurement will be? Who wants to take a guess? Angle 7. Look at our diagram. Who wants to take a guess as to what angle 7? Is that going to be? I'll give you a hint. It's either going to be 55 or 125. Angle 7. Huh? Why 55, Richard?
Wait, it's 4 125. Right?
Yeah, 4 is 125. Why is angle 7 55, Richard?
There's a pattern.
What is the pattern? Well, I know it. I want you to tell me.
8's 125. 8's 125.
All right.
One side's going from like big, small, the other one's going small, big.
And in the end, that's really what we have going on here. You all found the pattern in the end. And then 7 and 2, we'll just say angle 2 and 7 are alternate exteriors. But you also know that 6 and 7 are vertical angles. I'll accept it. I'll accept that's an acceptable answer. And then, but I like the fact that there was a pattern here. You're all seeing the pattern. And then 8, 5, 8 and 1 alternate exterior for. I'm gonna write that one over here. Well, I'm going to change interior to exterior. But yeah, there's a pattern. And I'm going to call it Because think about zigzag. See the diagonal, the zigzag pattern? You know what I'm going to nickname it? Give you a hint. Who is the cartoon character who has a zigzag for a shirt? Anybody know a certain very popular cartoon character? Give me a hint. He has a really famous dog. He has a yellow shirt, black zigzag.
Is it a dog? It's a dog?
I'm
Or
always
is it a,
like,
or is it a monkey?
No. His dog is famous too, but he owns the dog.
it's like a kid, right? Yeah.
It's like a kid, yeah. He has a famous zigzag T-shirt. You know.
He was in the papers.
Oh yeah. Here's who his dog looks like.
Monkey dog. But is I know it. Charlie.
Peanuts?
It's the Peanuts, Charlie,
And Snoopy.
it's Snoopy and Charlie Brown.
I forgot Charlie's last name. That's fine.
That's all right. But yeah, he wears the zigzag T-shirt.
Once I saw the dog, I automatically knew it.
So think about this like the Charlie Brown zigzag shirt. He's always wearing the zigzag T-shirt. So yeah, I call this the Charlie Brown method because the numbers zigzag. See how they zigzag?
Oh, that's what you did.
And his zigzag T-shirt.
Oh, I see.
All right. So here's what we're gonna do.
After I do the last one.
We're gonna start on some of these. We'll maybe get like one or two, but bring this back. Bring this back for next time. But we're gonna start on one or two. So okay, so don't put it away yet. We're gonna at least first talk about the first two problems, but bring this back because I want to also talk about the back.
Oh, this two?
Yeah. Because yeah, definitely bring that back. Bring this back for next time. All right, so what we're gonna do now, here's how we're gonna solve these types of problems. When we look at each problem, first off, we're gonna look at our two angles. Notice where our two angles are located. We need to figure out, given the location, what type of angles do we have? So that's your first step. So who could tell us what type of angles we have here?
Corresponding.
The corresponding angles. Now, if they're corresponding angles, what's their relationship? If you look on the previous page.
Consecutive and interior? Oh, wait, no.
They're parallel lines.
Okay, we have parallel lines, but what's their relationship? If the two angles are corresponding, that means they are
Corresponding is possible.
not. Don't use. What's the underline word?
They're in the same spot.
They're the same spot. That means they're congruent. That means so they're congruent. So that means what's their relationship? Do they add up to 180 or are they equal?
equal.
You said equal to each other. Congruent, you're going to say your 5x equal to x plus 80. That's going to be what I want. That's what we're going to be doing. Congruent, that means you said equal. Said equal to each other.
So then minus the x, we can basically minus 1.
Yeah, so then we just solved. So minus x.
Now give you 79.
What's that?
79.
Minus in the x's. What's one x? So you have an x, but I'm going to take it away.
4.
So over here,
Oh, I
5 minus
80.
4x equals 80. And then what's our last step? By? Divide by 4. That's our goal for these. That's our goal for these types of problems. What type of angles do we see? What's the relationship?
And then the next one is alternate interior.
Okay, so then the next one, yep. So the type of angles, and we'll talk about alternate interiors. Very good, Brooklyn. Alternate interior.
They set angles equal to each other.
They're congruent, so set them equal to each other. That's right, you both are right. Congruent. Set equal to each other. Set equal to each other. So what would be a setup for this equation? What's a setup here?
2x. That's 2x minus 10.
Okay, so you both were right. I know where you two were going. Exactly. Then the equation is going to be, you could set it up at 65 minus x equals 2x plus minus 10, I'm sorry. But if you had it 2x minus 10 equals 65 minus x, that's right. They're both valid. Just as long as you put an equal sign between the two. That's what I want. That's the most important part. So you could have it this way, but as long as you put an equal sign. So you put equal. And then how we solve for this?
Plus the x.
All right, I'll give you that. You can plus x. All right, we're not done yet.
It's going to be 3x minus 10. And then plus 10.
All right, so plus x, good. And then after we move the variable, you have to move the constant. So it'll be plus 10. All right, I see what you got. Yep, okay, so
It's going to be 75.
so 75 is going to be 3x. And then, Nelson, I think you said it. You got 25 because what did we do to both sides of the equal sign? Divide by 3. And then we have x. 25 equals x. So 3/4 is 75. 25. 1/4. So that's going to be what we're going to be doing. Now, we're going to talk about the back side when we come. That's going to be the very first thing we do, so do not lose this packet. Now, the homework. I'm going to give you the homework. You can probably knock this out by next class. The homework is really what we did on the top of this page. So if you understood what we did on the top of the last page of the notes, not the very last page, but I'm sorry, the notes we were talking about here. If you understood all this part up here, you understood between here and here, the homework, you'll knock it out in 5-10 minutes max. That's how quick this next assignment is. Now, do bring the packet back because we will do some of those problems on the very back. I do want to talk about some of those. That's probably going to be our warm-ups. Do now. All right. Questions for me? And again, notes will be posted tonight.